So some of the ways that some technologies that we have used to make um, to reduce emissions and reduce releasing pollutants into the atmosphere. One of the things is a couple of things are called baghouse filters, electrostatic precipitators, and scrubbers that physically remove airborne pollutants from a smokestack. So when a factory is releasing the smoke from a combustion reaction, this would actually remove the airborne pollutants from the smokestack. So the first thing that happens is that the dirty flue gas would enter the scrubber. So what's coming out of what comes out of a chimney, it goes up, the gas rises towards the spray nozzles of mist of chemically treated water. So the mist captures the pollutants and brings them to the bottom. So the mist is grabbing the pollutants out of the gas and bringing them to the bottom. And then the excess mist condenses on screen up here. And so then the purified flue gas exit to stack. So they've taken all of not all, probably hopefully most of the pollutants out of the smoke. So that leaves, then the dirty water is drained to a settling tank and cleansed, and then the water goes back again. The water is piped up from the settling tank and reused, and the sludge of pollutants is disposed as hazardous waste. So that's a way to get the smoke that's released from factories to be a lot cleaner. We also have these things called catalytic converters. Which are in cars that help them release less pollutants. And so they contain metals that react with hydrocarbons, carbon monoxide, nitrates in vehicle exhaust, and convert them to carbon dioxide, water vapor, and nitrogen gas, things that are much less harmful for the atmosphere. So this will cut down on pollution from automobile exhaust. And at first, these methods were resisted because they cost a lot more, but now they're widely adopted once policy mandated them or encouraged them. Also, we phased out leaded gasoline by the 1980s, which dramatically reduced its level in the atmosphere. So the EPA estimates that between 1970 and 1990, clean air regulations and technological advances in pollution control saved 200,000 American lives. So I said this at some point earlier in this lesson, that fixing air quality has been one of the successes of humans in regards to environmental issues. So we've safeguarded human health and environmental quality. This is a catalytic converter. So pollutants from the engine, because there's combustion happening and so pollutants are released, they flow into the catalytic converter. The inside of the catalytic converter, so that would be carbon monoxide, nitrogen oxides, and hydrocarbons. And inside of the catalytic converter, there's a honeycomb-like masses inside a stainless steel housing, maximize surface area with contact for gases. So the gases are going to have a lot of places to touch inside of here. And so there's all these metals. I'm covering this, but the metals are covered with aluminum oxide, palladium, rhodium, and platinum. And so what it does is the metals in the honeycomb catalyze chemical reactions with which heat and oxygen convert pollutants into nitrogen, carbon dioxide, and water vapor. So if you remember back to chemistry, a catalyst is something that gets a chemical reaction going that might not have started on its own. So inside here, there's all these catalysts, all these metals that allow carbon monoxide plus oxygen to turn to carbon dioxide. That hydrocarbons plus oxygen become carbon dioxide and water. So these things over here that are being released are much less harmful than the pollutants that would already be there. And then the less harmful gases are expelled from the vehicle's tailpipe, like nitrogen gas, carbon dioxide, and water vapor. So that is how a catalytic converter works. So today, the EPA and state agencies monitor the concentration of 6 criteria pollutants that are known to pose substantial risk to human health. Each pollutant has an ambient air quality standard, which sets the maximum allowable concentration for each pollutant in the air. And so there's 6 of them. 4 of the 6 include carbon monoxide, sulfur dioxide, particulate matter, and lead. And then there's 2 more that we haven't talked about yet, which is nitrogen dioxide. It's a highly reactive, reddish-brown, foul-smelling gas that contributes to smog and acid precipitation. So that one is not good. Then there's also tropospheric ozone. So we talked about this, how the ozone is supposed to be in the stratosphere. That's where the ozone layer is. But there is sometimes ozone in the troposphere, meaning our level of the atmosphere, and it's called ground level ozone, which is a secondary pollutant created by the reaction of nitrogen oxides, and VOCs when the sunlight hits it. This is bad because it is a major component of photochemical smog and poses health risks. And basically, ozone is a really unstable molecule. It's O3, and so what happens is when it's in the troposphere, it that third oxygen can break apart, and so we have an O2 that leaves just fine, but the third oxygen goes rogue and can get into our tissues and then can be part of chemical reactions that really damage our cells and can cause respiratory problems. So tropospheric ozone is most commonly the pollutant that frequently exceeds its national ambient air quality standard. So there's usually more of this than there's supposed to be. So there are more than 4,000 monitoring stations that take hourly or daily air samples. And then this data is used to calculate the air quality index, a 0 to 500 scale, measuring how healthy the air is on that day for an area. And each of the 6 major pollutants is measured on a 0 to 500 scale. So it accounts for everything. So here they all are. Overall concentrations of criteria pollutants, so those 6 pollutants, in ambient air across the United States has steadily fallen since 1980. So you can see that we have been able to lower them a lot. So this is, this dashed line right here is the health and safety standard. So we have basically gotten them under it for right now by 2015. And so while the air in most urban areas still violates at least one ambient air quality standard, air quality has shown great improvement since 1985. So we can see that the red is 85, the green is 95, purple is 05, and the black is 2015. So there has been a lot. It has dropped really drastically if you look around. However, we still have, this is the number of unhealthy days per year, and we're still at 106 in Los Angeles. So that's not very good. And then we have things that are called toxic air pollutants, which are substances known to cause cancer, reproductive defects, or neurological, developmental, immune system, or respiratory problems in people and other organisms. So under the Clean Air Act, the EPA regulates 187 of these toxic air pollutants that are produced by a variety of activities. Some of these are mercury, which comes from coal-burning power plants, VOCs, which come those volatile oxygen-containing compounds, and which come from gasoline, and methyl chloride, which is found in paint stripper. And so based on monitoring at 300 sites across the US, it is estimated that 1 out of every 25,000 Americans has cancer caused by toxic air pollution. So it is really a problem. And it's highest in urban and industrialized regions like Los Angeles. Rural areas also have air pollution challenges. A lot of it is from agriculture. So there could be airborne pesticides from farms, industrial pollutants that are from distant cities. So remember that if pollutants have a long residence time, they are traveling and staying around. So they could definitely get some pollutants from distant cities. Methane, hydrogen sulfide, and ammonia from animal waste in large feedlots, as well as fumes from natural gas extraction sites. So there are still air pollutant dangers in rural areas. And air pollution remains really severe in industrialized nations. So air quality is worsening in many industrializing nations as a result of proliferating factories and power plants, automobiles, and the use of wood, charcoal, and coal for cooking and home heating, because the governments are really pushing on economic growth, and that economic growth comes from these factories, which are polluting the air, as well as more and more citizens drive cars these days. So a lot of these power plants and factories that the government is pushing are outdated and use heavily polluting technology because it's cheaper and quicker to build, and they are industrializing. They don't have a ton of extra money to throw around. And so because of this, half of the world's population breathes air polluted at levels 2.5 times the World Health Organization standards. So half of the population, let's say that again, half of the world's population breathes air that is 2.5 times more polluted than the World Health Organization says is safe. It's not very good. So India, China, and other Asian nations are suffering the worst air quality, and this is a lot of because they tend to use coal to fuel their rapid development, which is the dirtiest fossil fuel, releases the most pollutants into the air. So in China's capital city of Beijing in 2013, pollution became too severe that flights were canceled and people wore face masks to breathe, and that the air quality index measurements were off the 0 to 500 scale, rating up to 755. During this time, there was a factory fire that went unnoticed for 3 hours because no one could see the smoke through the smog. And so this happened in 2013. The problem also returned in 2014 and 2015. And by 2015, the government finally was able to acknowledge that it was a problem and to do something about it and begin a public discussion about solutions. And in many Chinese cities, the air pollution is actually worse than in Beijing. So 1.2 million premature deaths each year are blamed on air pollution in China, and residents in northern China on average die 5 years earlier than residents of southern China because the air is cleaner in southern China. And actually, the pollution is reaching the West Coast, and scientists think that it adds at least one extra smoggy day per year to LA's total. So it's affecting us over here. And then we have India, where things are even worse. But the government has done things to improve the standards in China, and it has gotten a lot better. That differs from India, where pollution levels are even worse in Indian cities such as Delhi and other Asian metropolises. And according to a World Health Organization survey, 13 of the 20 most polluted cities on Earth are in India. And this is a lot of because of the many struggles with urban poverty. There have been few efforts to tackle air pollution because there's so many other things that they just don't think the air pollution is that important. There's a persistent 2-mile thick layer of pollution that hangs over southern Asia throughout the dry season each December through April. And they call it the Asian brown cloud. It has reduced sunlight reaching the earth by 10 to 20%, promotes flooding in some areas and drought in others by altering the monsoon, which is their really rainy season. So it's changing their weather patterns. It's decreased rice yields by 5 to 10%, speeds up the melting of Himalayan glaciers by depositing dark soot that absorbs sunlight, and contributed to many thousands of deaths each year. Okay, so then we have what's called smog. This is a specific kind of air pollution, and it's a general term for a mixture of air pollutants that can accumulate as a result of fossil fuel combustion, especially over areas with heavy automobile traffic. So cities suffer from a particular type of smog called industrial smog. So industrial smog contains carbon dioxide, carbon monoxide, mercury, and sulfur from the burning of fossil fuels. This sulfur will react with oxygen and water to form sulfuric acid in the atmosphere. So when coal or oil is burned, so that's down over here in combustion, so that's the lighting of carbon compounds on fire and a combustion reaction happens. When these are burned, some portion is completely combusted, forming carbon dioxide. Some is partially combusted, producing carbon monoxide, and some remains unburned and is released as soot. And so that's not shown here, but it does also show that, so there's the soot, the particulate matter. It doesn't show the carbon monoxide or dioxide, but it does show that sulfur dioxide is released. And then what happens is the sulfur dioxide will react with oxygen and water vapor in the air and create sulfuric acid. So this is what's known as industrial smog. America's worst industrial smog event occurred in Donora, Pennsylvania in 1949. Donora is located in a small valley and experienced a temperature inversion that trapped smog from a steel and wire factory for days. Remember, back to temperature inversions, it's a layer of warm air trapping cooler air below it. And what happened there was so this is located in a mountain valley, and one day after the air had cooled during the night, the morning sun did not reach the valley floor to warm up and disperse the cold air, so the temperature inversion trapped the smog. 21 people died, and more than 6,000 people, which was half the town, became sick in that Pennsylvania event. Then there was the killer smog that happened in 1952 in London that killed between 4,000 and 12,000 people, a smog event. So a high pressure system settled over the city for several days, trapping sulfur dioxide and particulate matter from the factories and the coal burning stoves. So that's pretty gnarly. We have a different kind of fog called photochemical smog, which forms when sunlight drives chemical reactions between primary pollutants and atmospheric compounds, producing a mixture of over 100 different medicals. So this is induced by sunlight. So ozone is the most abundant, and NO2 gives the smog a brownish haze color. That's why sometimes if it's super smoggy, it looks like the air looks yellowish or brown. Most urban smog these days is largely from car exhaust, and some emissions react with sunlight, so the pollution tends to be worse in cities with sunny climates, like our good old LA. So windless, warm, sunny days provide ideal conditions for the formation of photochemical smog. And so here's a image of it. So we have the hydrocarbons like gasoline or diesel fuel, and then our cars do a combustion reaction, which releases nitrogen dioxide, nitric oxide, VOCs, as well as carbon dioxide and water. And so these guys react with oxygen to create ozone. Nitric oxide reacts with oxygen to create nitric oxide,